Right, well, welcome to everybody here to our panel about slaying the two-headed beast, the challenges and triumphs of DNSSEC. So, as we just mentioned, okay, we've got some microphones here. That's good. We like to have that for our guests. This is part of the Deploy 360 program. As we mentioned before, we have a number of different parts to this, the web portal, social media, and other pieces, and we're active on social media. Our panel today, I'm going to ask them to briefly introduce themselves, and then we're going to get into a series of questions that we have. My name is Dan York. I work with the Internet Society Deploy 360 program. I've been involved in security and Internet issues for a very long time. And my particular focus within the Internet Society is around this topic of DNSSEC and DNS security. So let me turn it now to maybe Frederic, if you would like to introduce yourself.
Hello. So my name is Frederic. I'm working on StatDNS, which is a DNS research project. We are producing deployment statistics about IPv6 and DNSSEC within the GTLDs. We're also producing some open source DNS tools, one of which is used to power multi-location DNS looking glass, which can be used to make DNS requests over HTTP, and used to troubleshoot DNS propagation, anycast DNS deployments, and GeoDNS as well. Regarding DNSSEC, I'm also a user of this technology. On the authoritative side, I've signed some domains. I'm also experimenting with DANE, which should really push further. So I've then deployed on one of StatDNS domains, and also, of course, on the resolving sign, both on servers and at home. And that's it.
Great. Krzysztof.
Good afternoon. My name is Krzysztof Olesik. I'm DNS Technical Team Manager at NASK. I'm responsible for the technical operations of .pl registry. Thank you.
Hello. My name is Patrik Wallström. I work for .se and the OpenDNSSEC company. .se was one of the first TLD to be signed with DNSSEC 6 months after the standard was finalized. And we have discovered a huge number of bugs, and being the first player in the field is problematic, but we learned a lot from it.
Okay, well, so we've got a group of people out here at a network operators group. Let's maybe start with the basics of why should folks here care? What does DNSSEC do?
I can start with that. DNSSEC is the only way to secure DNS. DNS has, over the years, shown bug after bug with security issues and being vulnerable to different kind of cache bugs where you can inject false information in the DNS. So the only real solution to that is DNSSEC. There has been balance between fixing the bugs in DNS and the number of bugs that has been shown. So this is only working so far. I mean, in 2008, the Kaminsky bug was shown, and that was the day that the public was really considering DNSSEC for the first time. And the management actually understood why they want to protect their business by actually deploying DNSSEC. But since then, those bugs has been kind of fixed, but there's new one coming all the time.
Well, maybe that's a question, though, is how real are the threats to the DNSSEC, solves? What do people really need to be concerned?
Well, if you're on an insecure network, you don't know where your DNS information comes from. So that's the problem that the DNSSEC solves for you, if you run a DNSSEC resolver on your laptop, of course. Okay.
Any, Frederic or Krzysztof, any?
DNS is a huge database which stores many critical information for us. So bringing a trust into DNS is of a high importance. So the DNSSEC, I would say, is a must.
Okay. So maybe let's talk a little bit about, when we think about DNSSEC, there's different parts to it, right? There's signing and validating. Why don't you maybe talk about what are those parts?
Yeah, I think we have to mention, so we are using public key cryptography to sign DNS data. So in practice, like on the authoritative side, you serve your zone with additional signatures for each with record sets. And on the resolving side, you use a validating DNS recursor, which will fetch the DNS data and the digital signature and the public key, which you will use to verify that this data is authentic, and has not been tampered with or altered in any way.
Yeah, I'll show a little slide I put up here that just shows there's a signing side and there's a validating side. And those are really the two different parts that we're talking about here. Part of it is signing the domains, and then the other part is the actual validation of those domains. Maybe looking at Patrik, I know you folks have been doing a lot on the signing side, certainly. And maybe you could talk a bit about what the OpenDNSSEC project is all about or what it does.
Right. When we started with the OpenDNSSEC project, there was no real good signing software out there. What we did in .SE was basically doing it by hand almost. So what we wanted to do was making things like signing and key rollovers and everything automatic and being done by a policy that you want for your zone or zones. So we also wanted to do it in a very secure way by protecting the keys in a very good fashion. Most of the deployment that was done back then was using keys on disk unprotected. So if you had a break-in, your keys would disappear or ended up in the wrong hands.
So you helped automate a lot of that.
So we did a lot of work on that and integrating with the secure.
How about you guys? What are you doing to kind of automate that or the signing side of it? Do you work with that, or are you more in the validation?
On the authoritative side, I'm not automating anything because I use some zones which my zone data is not changing a lot. So I mean, I don't have to resign all the time.
Right.
And I'm using offline signing, which works for me in this case.
That's a good point, because for enterprises or others who don't, or zones that don't change, the need to have automated re-signing is not as critical. It just means it's more of a manual process when you go to re-sign that. Automated signing obviously makes that better and makes sure it happens. But the key point is that when you do change your DNS zone, it has to be re-signed in some way. Krzysztof, how about you?
We do re-signing the zone 3 times a day because we work in a mixed model. We use dynamic updates, and we also have full export of DNS data into DNS system. So we have to resign the zones 3 times a day. But the system is fully automatic. With the DNSSEC, we have to remember about the generation of keys, and then remember about the publication of the resource record at root. So all the system is automated. We used scripts, custom developed scripts, and the tools provided with the DNS software.
So this was your own scripts you developed along with some of the tools that are provided with the DNS server software?
We use tools provided by the developer of the DNS software, but we write wrappers for the scripts to make it more automated process. Okay.
Well, what are some of the benefits? I mean, what can DNSSEC offer people beyond obviously the security of that? What else can it? Why should somebody get involved with this? Why are we here?
Well, in the web browser, for example, you trust your DNS, and in theory you can also begin to trust the keys that you use for SSL sessions. So if you put those keys in DNS, you have an automatic trust in the root of the DNS as well as the certificate served from the web browser. So in combination, you can really trust the website.
So that raises a good question. Why can't I just trust that fancy extended validation SSL certificate that I bought? Why can't I just trust? I've got that. Why do I need DNSSEC?
In SSL, you have like 200 or more SSL roots, and you trust all of them, and you don't even know who they are. So that could be a problem.
So what you're saying is somebody could spoof my certificate?
Yes.
Is that easy?
Well, if you have control over a CA, if you're not the government.
Has there been?
It is possible.
Have there been mistakes like that happened?
A couple.
Gee, funny about that. There's the other basic detail, right? That in order to get that certificate, they have to get to your web server. So if somebody hijacks the DNS and points it to somebody else's site, it doesn't matter what certificate you have, right?
Well, you can have multiple trust paths, so you can still trust the CA as well as DNS, and the third party if you are one of those paranoid guys.
So what we're talking about here is a part of DNSSEC called DANE, or it's an extension to it, RFC 6698, which is a way to store certificates or fingerprints of certificates into DNS, and then have DNSSEC ensure that. Frederic, you mentioned you've been experimenting a bit with DANE. What are you doing with it?
I simply deployed it with a CA signed certificate in order to make sure certificate is not spoofed or like. We have maybe to mention with SSL you are only guaranteeing that the endpoint you are connecting to will be encrypted, but you have actually no guarantee that the endpoint you are connecting to is the one you want to reach.
Right.
There could be man-in-the-middle attacks, and that's why with DANE you're publishing fingerprint of your SSL certificate to ensure that the endpoint is actually the one you want to reach, or you want your users to reach.
Yes, so that you're using the correct certificate too. Any more thoughts on DANE? What else have you done with it?
Yeah, when DANE hits web browsers, when they can actually consume DNSSEC and TLSA records in DNS, the packets in DNS will grow so big that most home gateways, your home routers, will not do your big DNS packets for you. That is still a problem. That's why we work in the home networking group in ITF to actually fix and make it possible for the web browsers to have this extra security.
Sounds good. Just to illustrate this, I have a slide that I'll throw up here that just shows a picture over here and of the typical kind of interaction that you have to go out and find the IP address, and then you're connecting to a web server and you're getting back a TLS or an SSL certificate. But the question really is, how do we know it's the right one? And that's what this whole thing with DANE is bringing about, is this idea that you could check your web browser could check that the certificate that it got from the web server is the same that came down out of DNS through this TLSA record. Now, what other things are people doing with DANE beyond web browsers?
The easiest protocol to deploy right now is SMTP and XMPP, because that's mostly server-based software, so you can actually not be stopped by the home gateways.
So XMPP is?
It's a Jabber chat software.
Jabber chat.
Yeah.
Yes, okay. And what was the other one you said?
SMTP, that's email.
Email. All right, there we go. So I pull you out of the IETF geekisms into the regular language. And have you, Frederic, have you tried any of those? Or?
On the SMTP side, no.
Yeah. It's a new thing. I mean, one of the things we've seen is that DANE has this great promise of this extra trust layer in web browsing, but the web browser vendors so far have been a little bit reluctant to go and add DANE in. Part of it is that they say they haven't heard the demand. It's that classic thing that they haven't heard people asking for it. Another part is that it does add an extra bit of validation to go and do the process, and the browser vendors right now are incredibly focused around speed. Has been one of the challenges that their pushback to us anyway has been around why they haven't done that. But what's interesting though is, to Patrik's point, we are seeing people in the email world looking at how to use this. There's some folks playing with DANE in the VoIP world, looking at how they can use it to better secure SIP endpoints, so IP phones and soft phones and things. I saw that Paul Wooters had put up a couple drafts around how to use it for PGP and for a couple other different kinds of things. So people are trying to experiment with that. On the validation side, switching kind of to the other side of things, when I talk about validating domain names, what's stopping people from doing validation today? mean, let's back up. What's the process of validation? Could one of you explain that?
Validation is to actually look at the digital signatures that DNSSEC adds to DNS and verify those so that it can actually be verified from the root down to the record that you asked for.
So I'll use a signed domain that I happen to know, internetsociety.org. So I want to go to www.internetsociety.org. So my web browser tells my DNS server, get me the IP address for www.internetsociety.org. What does a validating DNS server do there?
It looks at the signature and then it asks for DNS keys to match those signatures all the way up to the root.
And what happens if the signatures don't match?
The problem with DNSSEC is that you don't have a specific failure mode for DNSSEC. So you get a serve fail, which is any kind of problem with DNS. So you don't know why things break.
But from my experience,
you don't reach your destination.
I don't get there.
Exactly.
Yes. And there's been some early adopter challenges with that. There've been we've had a couple instances. The most famous one was the NASA issue where NASA let their key signatures lapse, and people who were on Comcast network in the United States were unable to get to NASA's website, and it immediately happened. It happened to be on the same day that, if you recall, Wikipedia was going dark with all the SOPA, PIPA stuff that was going on in the US. And so it became this big conspiracy that everybody thought that something was going on, but it was not. It was an error. It was somebody had made a mistake on that line. But it points to your point about the automation that's needed that you talked about earlier to kind of make some of that happen. But so the validating servers, and I just mentioned one deployment in the United States, but I know your country, I know Sweden has a lot of. Can you talk about how the resolvers are validating there in your country? Are most ISPs?
Yeah, the most resolvers are ISPs, so all the big ISPs are doing validating DNSSEC right now. So that's been quite easy process. Since we were there from the start, we can actually convince ISPs to turn it on. And back then there was basically very few signed domains,
right.
So you didn't see these errors. But right now we have 1/3 of the .se zone with signed domains. So that has been a slow learning curve for everybody involved. But now most of the ISPs are doing validation.
And I know that nearby here, I know the Czech Republic has also been the folks there have been very active getting their ISPs to sign as well, or not to validate. So we're getting the validation, and this is part of this DNSSEC bootstrapping problem. We need to have DNS resolvers out there that are validating, and then we also need to have domains that are signed. So it's these two different pieces that are there. And you all as network operators who are here, part of what you can do when you go back is look at how to go and enable resolving or validation on your resolvers. Is it hard? No? Okay. You said you should. No. What do you have to do?
Well, you just have to configure your DNS server to
Is it
make
a big,
validation.
long process? Big, long process?
No, it's just configuration option, and eventually you have to make sure to provision enough boxes in order to, because your CPU usage will, of course, go a little bit higher as you are doing validation.
Now you just said a word that some operators might be wondering about, provisioning more boxes. What do you mean?
I mean, you have to make sure that your server are sufficiently powerful to be able to validate requests for each request. Like if you have a lot of customers or...
So you need some servers to be sure you've got enough capacity. Krzysztof, you were shaking your head a little bit there.
Definitely, you have to cater for CPU, that you have to have a greater CPU, more RAM, and definitely a bigger link to the internet.
Because you're getting more...
Because the responses of DNSSEC, yes, definitely, you have to fetch more DNS records to validate a DNS response, and the responses you send, you receive are much bigger. It's like 4 times or 5 times bigger.
Because you've got that key in there rather than just the single little response. Now, you implemented DNSSEC under .pl here, right?
Yes.
So what was involved with that?
What was involved with that? Yes, there were several challenges. I would divide them into 2 categories, technological one and the operational one.
Technology and
technological operation. From the point of view technology, we have to learn how to use HSMs. It was new technology for us. There is a special specification called PKCS 11. It's
let's back up for people who are out here. Yeah. What's an HSM?
Oh, I know. It's a hardware security module. It's a device designed for storing a cryptographic material in a secure manner. So it's tamper-proofed.
So it's a box
that's certified by special organizations who said, guys, this is really safe.
Right. So it makes sure that those keys are secure and protected. So you need to get a couple of those to make that work in there.
Yes.
Okay.
We have to test several devices because we have to make sure that the capacity of the device is sufficient, and DNS software want to talk to the device and they communicate. That was the biggest challenge.
Okay. And what other challenges you said?
Yes. And the operational one, when you think about the security, you have to consider who should have access to the keys, how to organize key rollovers. There also who should take part in the disaster recovery and prepare all different stuff of information, communication outside the company. It's a lot of things to be aware of, you know. Mm-hmm. That was a challenge too, because we have to produce lots of documents, and engineers don't like to write documents. You know, they consider it as it's a waste of time.
But now it's signed. It's
It's
operational.
signed. Fortunately, it works well. We didn't have any accident yet.
Good.
Yeah.
And now,
so far, so good.
And now part of this, though, too, is now that .pl's been signed and pieces there, if I want to take my domain that's in .pl and I want to register it, or I want to sign it, I can sign it.
Yes. And
now I have to somehow let .pl know it's signed. Are you working with the registrars in here?
Yes, we had several meetings with registrars even in the past years. First, we've been talking about the DNSSEC, about the technical aspects. We trained them how to use the DNSSEC, what's it for. And this year we had a meeting with our registrars, and the meeting was focused on the benefits of the DNSSEC. What will be the benefits for the clients of registrars and for them itself.
Good. Well, I wish you the best with that. That's one of the challenges we've certainly seen in different areas, has been to encourage the registrars to be able to help with the transmission. There's a key part. They have to take the DNS, the key, and transfer it up in what's called a DS record. And they have to transfer that up to the top level domain. I know, what happened in Sweden to get registrars using that?
Well, the first year we actually considered DNSSEC to be in production in 2007. We actually charged extra for publishing DS record in our TLD, which was a failure. We want to encourage people to secure their domains. So now they turned it upside down. So now it's actually cheaper if you add a DS record. Yeah. So that's how you do.
Okay.
It should cost extra if you want to do insecure DNS.
Insecure. So it costs less to have a more secure domain. I like that. That's a good way to go. If you're a TLD that can do that, it works.
So that has been quite successful, and that's the common thing between the TLDs that have a lot of signed domains, that it's cheaper.
So the TLD, the registry, has done that, which has then provided a financial incentive for the registrars to go and make that work. Interesting.
Yeah. Because the registrars don't earn their money on DNS, they earn it on other stuff.
Yeah.
So that's one way of making it happier.
Now, one question when we talk about that is, on a certain level, shouldn't DNSSEC kind of be transparent to the end users? Do they need to care about it? Or should they be warned about it? What do you think about that? Frederic, do you have some thoughts on that?
Yeah, so we must differentiate authoritative side and recursive side.
Okay.
On the recursive side, I think the answer is probably yes. And we have seen this with, for example, Comcast turning out DNSSEC validation silently. We saw that it didn't really break anything, except that sometimes some failure, like it's a NASA one. We've seen also Google Public DNS turning on DNSSEC validation, and it was a huge milestone.
It was.
There was actually some studies on DNSSEC deployment on resolving side, and we saw that suddenly, like a bump of people validating, like were from 3 to 8% or something like that.
Do people know what Frederic's talking about? Google operates its public DNS servers, and just earlier this year they turned on DNSSEC validation by default, so that anybody who's using Google's public DNS servers now just gets this automatically, transparent to them. And some individuals use Google's public servers. Some ISPs, especially some smaller ones, turn out to use it. We discovered one of the people presenting at one of the conferences from APNIC, who was presenting some of his research, discovered that some countries, some large ISPs, turn out to use Google's public DNS servers. Now, whether they continue to with all the current discussions around surveillance and stuff, who knows? But at least there was that. And we saw a big jump in the rise of validation. Okay, so that's the validation side. So for the end user, it should be transparent. It just works.
Yeah, probably.
So operators out here, they could just turn it on and it should just work. I mean, the end users don't need to know.
Well, this was a question of what to do in case of a validation failure. We may ask, like, if it will make sense eventually to validate in application directly. For example, for web browsers, like what to do. Should we allow users to go insecure, just like we do with SSL certificate? In case SSL certificate is expired, you can choose to go to the site.
And how many people here click through those boxes? Right? Okay, yeah, it's one of those challenges. But so allow the users. Patrik, you look like you want to weigh in on this or something.
Yeah, the hard part of DNS is that users don't know what DNS is. But if they know what DNS is and they have problems with it, they change their resolver. So if they change it from a secure resolver to an insecure resolver, it probably work. Or they are probably under attack.
You know,
it's
funny,
hard to tell the difference.
Yeah, you're right, because when I think back to that, when Comcast had that issue with NASA, there was immediately a flood of articles out in blogs and such that were being spread around on Twitter and stuff. Well, here's how you fix this. You change your DNS servers, probably Google's public DNS or somebody else's, something like that, to some other OpenDNS servers or something like that. You're right, they'll change that. What else you were saying about the users, on the validation side? How about on the signing side? Should users have to care?
So I think yes and no as well. It's an open question.
Yes.
Now we're seeing in countries which have a lot of DNSSEC penetration on the authoritative side, like Sweden, for example. You see some registries are offering some one-click solution way to enable DNSSEC. Mm-hmm. So, I mean, for the end user, you just have to click something and all your keys are generated for you. Key rollover are being managed for you. And the register also uploads the DS record to the parent zone. So in this case, it's like entirely transparent for the end user.
Cool.
And in case you have, like, for some organization who have more complex needs, so of course they have to be knowledgeable about DNSSEC. And
there is a little bit more they have to be concerned about. Are there questions from the audience, by the way? I mean, I've got a load of questions I can keep asking folks, but Natalia's here with a microphone. If anybody has any questions, you're welcome to ask them. Otherwise, I'm going to keep on going. Well, we'll keep an eye out for that. How do we accelerate? How do we get more people using DNSSEC? Any answers?
Well, I think you should do what most Linux distributions do right now. If you install your resolver, for example, unbound, it just turns on DNSSEC for you, and you don't even see it. That's the experience you want.
This is a solution for the experienced users, very experienced one.
Well, but if you install your Windows machine, it should do DNSSEC, or you install your web browser, it should just do DNSSEC for you, and that's how you do real deployment. But for that to happen, there's a lot of work between here and then.
Yeah, I think I recall, I might have even written about it, that there was I think one of the BSDs distributions is going to be coming out with. You're shaking your head.
Yeah, so what Patrik is saying, like Fedora started to bundle like DNS resolver with default configuration, defaulting to validating, to validation. I think Debian is thinking about doing this, like they signed their zone and they seem to be really interested about DNSSEC. And as we mentioned, like the upcoming FreeBSD 10, we'll have, they are changing the default installation to bundle unbound instead of bind, and to configure unbound to validate by default.
So we'll have at least those operating systems. Now, I mean, to your point, that is more of the experienced users. It's not my mother or people like that quite yet. But if we can, see that start to move out there, that at least works on one part of that. What else can we do? What can we do on the signing side? I know you.
As a TLD, you can make it cheaper, of course. But it's really hard to convince the government agencies and the banks to actually do DNSSEC, because it will be much higher cost to them than to a registrar, of course, because they only have a few domains, and they probably want to invest in HSMs and the security surrounding it as well.
Do you need an HSM to sign your domain?
Absolutely not.
Absolutely not. Yeah.
But if you're a TLD, you probably have you're up higher in the hierarchy where you protect a lot of domains under you. So that's the reason why TLDs do it.
Yeah, it all depends on your level of risk, right? Whether you're just an independent with a couple domains you want to sign, or a smaller company, or if you're, like you said, a TLD that has a very large number, or a large enterprise or something on that line.
But if the only thing you protect is your email, then probably not important with an HSM.
Any other comments here? Okay, questions? We've got network operators here. What should they do when they go back? What would you suggest for them to do? Any suggestions?
Take a piece of DNS software and try to sign, for example, some zone.
Take a piece of DNS.
Yes, exactly. To play with the DNSSEC and feel and see it. It's not difficult. It's not a two-headed beast.
It's not a two-headed beast.
Yeah, they are
We're slaying that
dragon
here.
slayers.
That's right.
Yeah.
Any other thoughts?
Antonon validation, of course, in their resolvers, because large operators have a large resolver for, basically all their customers that they recommend them to use.
Any thoughts for you?
Nothing really to add. Like, it makes sense to accelerate development on the resolving side, because if nobody is validating, there is no sense in having signs on. So
Right. And I think one of the things we've seen, what's an interesting effect of Google having signed their public DNS, was that we had a number of people at operators who contacted us and said, the good thing was that Google did this. So it provided them some ammunition to say, well, if Google can figure out how to do it, we ought to be able to do it. It was because they were getting pushback saying, well, nobody's really doing this. Well, now you could say, well, Google did this for the public DNS. So it's at least something on that line. And I think as we start to see more examples of more countries and more large ISPs and stuff do that, it will continue to go. Your point is right, too. I could say there's a great white paper that the folks at SurfNet in the Netherlands put out that talks about validation, and they show on the last page how easy it is to implement it in some of the validating resolvers like Unbound and Microsoft Windows Server and stuff. And in some cases, it's just one line of code. It's one thing in a configuration file. That's it. Go in there and change it. Change it from no to yes, or true to false, or whichever the option is, and boom, you're now doing a validating resolver. Oh, Marcin's got his microphone. There we go.
Hi. My remark would be I'm afraid of protocols without the user interface. It's the problem we mentioned about if validation fails, how to tell. I think SSL in the old days got really off because of that little padlock in Netscape and this annoying pop-up when you've submitted the form. And that was why SSL, because otherwise I would imagine we would be promoting SSL today. But the question is, do you know efforts of combining DNSSEC also with spam and mail abuse fighting things? Because, for example, what Google Mail is doing, they now report if your email has proper DKIM signature. then you can check it and you can see that somebody signed the headers of any email. Do you think that vendors or providers of email should work on this and include also DNSSEC? It's a natural extension of DKIM, I would say, to promote DNSSEC this way.
Yep. Any of you want to?
Yeah, I've seen a couple of smaller projects looking at how to verify email using DNSSEC and DKIM and stuff like that. Mostly within the Internet 2 project, but they also include some sort of picture in your email program show you that the validation has been done. I don't remember the exact details, but and I haven't seen any positive results from those projects either. So.
There are a couple drafts that have come out, internet drafts within the Internet Engineering Task Force that are around this topic. At one of the last meetings, Russ Mundy who works in some of these DNSSEC areas, was looking at one that was involved with some of the mechanisms for using it in SMTP. So there is some work happening out there in the standard side to look at how it could be used to help protect the email environment. And some of that is understanding who you're connecting to. Some of it is understanding who you're getting the certificate back from. If you look at it in the Dane environment, if you're using Start TLS and some of the components to go and create an encrypted connection for email, you could use Dane and the extra protection there to provide an extra layer. So there are people looking at that. Question over there.
Hi, Matthew Moorcroft. Given what Marcin was just saying about not having a user interface and users not understanding why they would get failure if we can't validate DNS, should we be running resolvers anymore? Should we, in fact, just push this down to the end user PCs and computers? They all are extremely powerful these days. DNS is becoming more frequently more dynamic. Are we buying anything by having resolvers at all?
I can answer that. I think the secure validation of DNSSEC should be done as close to the users as possible. So if you want to have a resolver in your home, that's better than having it at the ISP because the distance is much higher. But for the question about the user interface part of it, that was a very conscious decision for the DNSSEC protocol, because what you learned from SSL is that people absolutely click on the OK button to just access your web page. That is not for the benefit of the user. That actually makes it more vulnerable.
And I think that
a lot of what the problem you see when people's computers get rooted and taken over by various malware is that it doesn't really matter if the resolver's actually checking and that everything is good. If your computer is not actually aware of what's going on, even if you yourself just click on randomly, yes, that's fine, at least the user knows something's up. I guess, I've run resolvers in the past at previous companies and so on, and do we need them anymore? Is there a point?
I don't think not securing all of the protocols that you use on the internet is an excuse for not having a secure box.
And I think the reality, right, is that DNSSEC is just part of, your overall security strategy. Sure. It solves that issue of making sure that you get, the IP addresses you get back are the correct ones.
But my point is that it's not valid. Like nothing is seeming to validate from the computer to the resolver.
Mm.
And so, what if something in that path, I can't validate my resolver is good.
Right.
So we're not, we're doing all this lovely work to validate that it's good to the resolver. So what?
Well, but to your point, you can bring that resolver down into the operating system that's running here, like we've heard about some of the Linux and the BSD side, and or you can run your own. I run my own unbound resolver on my own laptop,
and that's my point. Should we be running resolvers at an ISP level at all?
Oh, yeah, at an ISP level. And that's a good question. And I think what we're seeing right now is we're seeing the initial deployment out at ISP level and other levels. What I hope we'll see is further bringing that down into enterprises and the homes. I think Patrick's note about some of what's happening in the home networking environment. People are looking at some of those, the HomeNet, HipNet, some of the pieces that are out there, looking at how do we bring that down into the consumer electronics equipment, and getting it down into your home router. And that's a good step. And then you could look at how do you even bring it further down into the operating system or even into the applications. And people can do it in all of those places. Good question. So we're kind of coming up on the end of our session, so let me ask you, as far as any final thoughts you want to tell to people out here as far as what they should do to get started with DNSSEC.
I don't think there is any excuses left for not doing DNSSEC, but
I like that.
For deploying it in your home, it's still a rough ride. But do it on your, corporate network. At least.
Do it on your corporate network.
Yeah.
From my perspective, it's better to do it now than later, when people will be more DNSSEC aware, and if there will be more assigned domain names. If something goes wrong, then the impact will be much higher and painful.
So learn it now before it gets so widespread. It's a good example, good thing for operators to think about.
Yeah, I think it's good advice. Because if you make mistakes now, once at the moment we don't have a lot of people validating yet. So, you can get around this. You can learn from the errors. Mm-hmm. It's especially important for key rollover. Once everyone is validating, you cannot afford to make this kind of errors.
Exactly.
So you better prepare for them.
Sounds good. Well, on that note, let me just wrap with a couple final little slides. One is a map that you can get from our Deploy 360 site that shows the top-level domains that have signed, and you're missing the borders. So over here is Africa. Okay, it looks nice on my slide, but the gray doesn't translate up there. But this shows the top-level domains. You can see a lot of the world has signed. A lot of the CCTLDs, almost all of the generic top-level domains, and all the new GTLDs, the new generic top-level domains that ICANN is going through this process of rolling out. Those all will have DNSSEC as part of it by default. That'll be part of it that's there. So there's a lot of action happening on that. I'll leave you with some resources. This is one of the topics we cover at Deploy 360. So if you go to our website and go to internetsociety.org/deploy360/DNSSEC, and if you go right to the basics page, you'll find some good information to get started that are on there. We also do have a page up about this thing called DANE, which is this way of putting SSL certificates into DNS and using them for the web, for email, for VoIP, for IM, for other different tools that are out there. So maybe there, and I mentioned here, again, there's this white paper from SurfNet is really good about the validating side, the resolver side. So as network operators, it's something you can take a look at and see what's there. There's a good long DNSSEC how-to, which is a pretty comprehensive document that gets into this. And also the NIST, which is the National Institute of Standards and Technology in the US, wrote up a document called Secure DNS Deployment Guide, which is guidance for US federal agencies about how to go and do it. But it's actually a really solid document for anyone to look at how do you go and securely deploy DNS in those types of things. So I'll end with 3 steps. I would encourage you, as we said here, deploy some DNSSEC validating resolvers. Sign your domains if you can. And also, if you're at an operator level, if you can look at how you can help talk about this thing called DANE. It's one of the ways that people are looking at how we can really use this. From a Deploy 360 program, we also are looking for people who have deployed DNSSEC. We'd like to do some case studies and some discussions and documents with you if you've been doing this type of thing. So I would like to just ask you to join me, please, in thanking our panelists for today.